Okay, for this example, we're trying to solve another inequality involving absolute value. And here we've got the absolute value sandwiched between 1 and 7, where we have an inclusive inequality here and a strict inequality there. So we're going to solve this one similarly to the previous example that we did. And that is going to be by sketching a graph of the absolute value function in the middle here, the absolute value of 2x plus 5, and then identifying the x values that satisfy these inequalities on the graph. So again, we have two transformations that have been applied here, and doing them in the correct order, we could describe this as a shift to the left by 5 units. That's the plus 5 on the inside, followed by a horizontal scale by a factor of 1/2, and that's the 2 on the inside. So tracking these changes, we start off with the basic absolute value graph that looks like this. We're going to shift this graph to the left by 5 units. So it winds up over here. And this vertex gets moved over to -5, 0. And then we scale it by a factor of 1/2. So we take each point and we move it closer to the y-axis by 1/2. So this -5, 0 now winds up at -5/2, 0. And we want to identify the x values on this graph that give us a y value which is greater than or equal to 1. And so for this, I'm going to draw a solid line because we're including 1, or less than 7. And so for that, I'm going to draw a dashed line because we are excluding the 7. We want strictly less than 7. So we see a picture of the region that the interval of x values that we're trying to find. Namely, those values that are in this green zone over here that fall between these two horizontal lines. And over here, I'm going to exclude this point of intersection. So I'm going to put a big open circle there. I'm going to exclude that one. And down here, we're going to include each of those. So putting this together, all together, we're trying to find the x values between here, excluding that point, over to this point, including that point. We include this x value where they intersect, and then we exclude this x value where they intersect. So just highlighting this on the x-axis, it's going to be the values in here and the values in here. All of these x values give me a y value between 7 and 1. So let's find what these values are algebraically. So looking at the lower inequality, we want to figure out where the black absolute value graph intersects the horizontal line through y equals 1. So we want to solve when is 2x plus 5, the absolute value of 2x plus 5 equal to 1. And that's going to give me the intersection points on the blue line. And so this would be solved by figuring out when is 2x plus 5 equal to 1, or when is 2x plus 5 equal to -1. And so we can solve that by subtracting 5 from both sides and then dividing by 2, and that would give me one solution over here where x is equal to -2, and a solution over here where x is equal to -3. So what I can see over here, this corresponds to x equals minus 2, the intersection, and this point over here corresponds to the intersection when x is equal to minus 3. And if I just zoom in on this interval that we've sketched down here, just to make these numbers more clear, I see that this is minus 3, that is minus 2. And then we solve the inequality, or for when it's less than 7, by finding out where the absolute value graph 2x plus 5 is equal to 7. That's going to be where we intersect the dashed line. And we solve this by figuring out when is 2x plus 5 equal to 7, or 2x plus 5 equal to minus 7. And solving this by subtracting 5 and dividing by 2 gives us x is equal to 1. And solving this gives us x is equal to minus 6. So coming back to our number line, we now know where these open dots are, where we intersect the dashed line, namely the one on the left occurs when x is equal to minus 6, and the one on the right occurs when x is equal to 1. So writing this out in interval notation, the solution here is going to be all x values strictly bigger than minus 6 and less than or equal to minus 3. That's the green interval on the left. And then we pick up again when we hit x is equal to minus 2. We include that up to, but not including x is equal to 1. So there we have our solution in interval notation. This identifies all of the x values on the graph of this absolute value that fall in between these y values. That's highlighted in green.